Hello everyone, I am Xiaogang. Okay, let's talk about the most complex part of the TMap. First, we will discuss the overloaded operators like equality and the overloaded hash function. We will look at that later. It's when we know in TLV that you want to put a structure into TLV and perform operations like this. When judging if they are equal, you must overload the equality operator. In hashing, you not only have to overload the equality operator, but you will also need to write its hash function. So we've already written this part. So how should we write this? It's actually pretty simple. If you don't know how to write it, you can actually just paste this function. Then you go into the engine and search for it. And then you'll find that the engine actually has this function in many places. Look, it's also a struct. So literally speaking, the struct might be, I think it's located in this position. Let's guess. I don't really know what this is used for. There are no comments either. Then let's ignore it. Look, it's just like this. Define several attribute variables, then overload, etc. operators, then overload, so we can also write it like this. Then here, let's assume we define the info for a map. And this info is information about the NPC in the scene. If we use this info and put it into a map, using it as the key, and the count is the value, then we can know how many in the scene of that type of NPC there are. And if this NPC might die, it might be alive. So we will record its life value. This side provides it with the default initialized variable. And as for this boolean, it is from the AND operator here. As long as we assume that this NPC has the same name, we assume it is the same NPC. And this place is the GetTypeHash. We will directly use its FString here as a GetTypeHash to use it for this operation. And this place seems to be, the case might be case-insensitive. Okay, then after we have it, we will write our own straight map. Once you have defined it, then we can write this map in the straight section. And then the first one should be FXTF-info. Then the second one is defining its quantity. Let's use the Intel 332-1 MP seats. Pick. Then at this location, we will, let's add an NPC. Then it seems we didn't write its constructor function. We will write its constructor function here. Then we have the default constructor function. We need to select two functions. Let's set up one for everyone. Give it a name, NPCInfo. This spot is obviously a small mistake. It's misspelled. This should go here. Place it here again. Okay, and then let's take a look. It should compile, right? This spot might require a default constructor. We'll write a default constructor here. If we fix it again, there shouldn't be any problems. Okay, here we add, for example, a boss into the scene. Okay, we set the quantity of this boss NPC to 1. This spot, in this area, we might need to write it like this. Writing it this way is fine. Okay, this is a C++ command. We won't emphasize it here. If anyone isn't clear about this, let's learn about how this displays videos. By learning about these related things, you'll understand. Actually, for this behavior, we constructed and added such an object to it. Then, we give a player here. We give a 2. And then, we give a player. Let's use true. There's an object named true in the scene. Okay, now, let's execute it. Let's see if we can, at the same time, let's verify it. Is this writing it this way, case-insensitive, right? We will change this to 3 here. Actually, there is another classic way to write this. After we successfully validate it, I will show it to everyone. Let's just move on. Okay, the breakpoint has been reached here. After entering, let's look at this area. Okay, this is our map, right? There's also an entrance here, and a particularly special point. That is its k value as a structure. A boss 1. Its value is 2 in number. Then let's take a look here. We forgot about this part again. It's empty. So let's ignore it for now. So this spot doesn't write sensitively. It should perform a negative write on it. So actually our most classic approach is like this. We rad, and then we add something called, we call it solder, or we can call it enemy. Let's call it little soldier lomo enemy. Then we add 1 to it, a quantity of 10. Actually, this place shouldn't be called add. More accurately, it means checking if there is any. If there is, we overwrite it. I have it. If there isn't, then we add it. It's roughly this idea, right? Let me check. Because it returns a reference to this object, so we will ensure that it has this LOMO enemy. And ensure there are 10 of these LOMO enemies inside. Then we will proceed to perform a simple operation like the. Note that at this point, we are not getting into it. Is there this thing with 10 enemies? We say that regardless of whether there are 10 enemies inside, we will go in and set it up, ensuring that the next step definitely has 10 enemies. It's an operation like this. If you say that you want to write this, for example, if there are already 2 characters in the scene, then I add 10 more character. So there should be 12 minions in the scene, or there is only 1 minion in the scene. I will then perform this operation again. There should be 11 minion in the scene. So you might have to write some slightly more complex logic. For example, the logic could be written like this. That is to say, let's see how it would be better written here. Actually, writing it this way is quite... I'll write a comment for you like this. Guaranteed to have. It's guaranteed that there are guaranteed to have 10 lows. Meaning, regardless of whether they exist in the current scene or not, it's guaranteed that there are 10 lows. Then we can write this section to ensure there are 4 players. Ensuring there are at least 4 players. At least 4 players. So what should we actually write here? This is also pretty easy to write. We can write it like this. As for the IDD of 3, in this spot, how can we do it? We don't seem to need to go to this place. I was wrong. I shouldn't write it this way. Take a look. This is correct. We will review this no matter what. Actually, this place here is inter32. What I mean is our player number. This thing, it should be like this. And then on our side, we just need to participate. We only need to use the letter K. Yes, it should be like this. Now let's run this. This point is actually special. You can see that. Actually, if you look at the spot, it passes this. It can pass a value. You will find that this FindORadd is similar to the previous FindORadd we used. It's equivalent to having an overload. You can see it has some simple overloads. You can see what we used before was this one. Actually, the one being called now is this one. Okay, so pay attention to the distinction in this area. The difference in this place is ensuring that this number has an item of 10. It's set to 10, regardless of whether it previously had any or how many. And in this place, we get this. Then, we need this reference. We get this thing. If not, we will add a default one. So it should be 0. So I set it to equal 10 plus equal to 4. Okay. Right? We guarantee at least 4. Note and understand these 2 things he said. Then we'll set a breakpoint for everyone to take a look. Okay, we've hit the breakpoint. After coming in, we added this element here. And then you will see, let's take a look. Our current player, you will notice it is 3. This proves that case is insensitive. The way we write it now is case insensitive. How can we make it sensitive? We let this hash so that its case results in a different hash. Then it will be sensitive. You can write some hashes yourself. You can code the algorithm or wait and use that CR later. Using this, he should be fine. Use this to write this type of transaction. It's equivalent to hashing it out differently, isn't it? Yes, okay. So in this part, as you can see, our side doesn't have the n examples. So let's add it now. So it ensures that there. Let's check to make sure there are 10. See, there are 10 here, right? There is no problem. And right now, we already have these 3 players. So What we got is 3. Let's change it to 4 first. So this is equivalent to us adding 3. Adding means 3 plus 4 equals 7. So 7 players. So actually this is compared to our structural design, as a case shape, a little bit more complex. Applied like this, if you are not used to it, you should still put this structure into this Y6 child. Then with this K, you can use some unique IDs for labeling. In the next lesson, we will cover this section. How do you often use this unique ID, or rather your TMap? If you are not used to it, you can direct use touch. It creates a large struct and then wraps up all this information. Doing it this way is also fine. It mainly depends on everyone's. Combine it with your own level of programming habit. Okay, thank you all.